User interfaces have gone graphic, business correspondence has gone graphic, and now programming itself is going graphic. This is Multiscope, a graphic debugger for OS/2. This is not your father's Oldsmobile. This is a new generation of programming tools, environments, and languages. Today, we take a look at the new object-oriented programming languages on this edition of the Computer Chronicles.
Computer Chronicles is made possible in part by the Software Publishers Association, which reminds you that software piracy is a federal offense. When a few people steal software, everyone loses. Additional funding is provided by CompuServe, by PC Connection and Mac Connection, by Byte Magazine and Bix, the Byte Information Exchange, and by Intel Corporation, Personal Computer Enhancement.
Welcome to the Computer Chronicles. I'm Stewart, Cheifet, and with me this week is Jan Lewis. Jan, we're talking about object-oriented programming languages, a new approach to programming. This is an interesting example I have over here. It's a relatively simple program called England, but it lets you program even though you don't know anything about programming. It automatically writes the code for you. For example, I just get into a dialogue here. I say, I want to W, write a program. What do I want to do? Well, let's say I want to use a math command. Which one? Let's say I want to generate a random number. I hit 2. Let's say a random number from 0 to 1, I hit 1, assign it to a variable, I'll say X, and there's the line of code it's written for me. I don't really know what the code is, but it tells me that's the first instruction. And you can do serious things with this. For example, I can go back and run a program I wrote before dealing with the generation of invoices, and there you go. And this is a pretty complicated program, in fact, which checks me on quite a few things. And what is interesting, if I want to debug it, I can go in here to View Program, view the program in memory, and there's all the code that the program wrote for me just there, and I can go in and figure out how to change it and so on. Jan, we're talking about, as I said, the OOP languages now, and it's a little bit complicated, I know, but can you explain in simple terms what is object-oriented programming compared to old-fashioned procedural programming?
Sure. Technically speaking, this is not an object-oriented language.
Right.
However, it demonstrates the benefits. First of all, you can develop an application without knowing how to write code. Secondly, you can develop for the graphical user interface environment. And thirdly, you can easily change or debug that code. The object itself, the concept is the object stores the functionality and the data, and then to activate it, somebody sends it a message, and it just takes off at that point. One of the reasons that object-oriented programming languages are on the rise because of the sheer complexity and size of today's programs. To find a simple application that has 500,000 lines of code is simply not unusual. So as the complexity and the size of programs increase, we have to come up with ways of making it more manageable.
Jan, we'll take a look at several OOP languages today. We'll look at Smalltalk and Actor, C++, Objective-C, and Prograph. When you talk about programming languages, one company's name comes to mind, and that's Borland. Borland, of course, made a business of selling Turbo C, Turbo Pascal, now Turbo Debugger and Turbo Assembler. We begin with a visit to Borland headquarters in Scotts Valley, California.
Borland International is perhaps best known for its Turbo language products, such as Turbo Pascal and Turbo C, two structured programming environments that have sold well over 1 million copies. They're part of what Borland President Philippe Kahn calls the first software revolution. In spite of similarities, the two languages have dissimilar markets.
Pascal is more of a university tool, actually, which is used a lot to teach computer science courses and data structures or the first-tier classes, and hopefully it's now moving into high schools and replacing BASIC. C is more of a systems programming language. A lot of commercial software is written that way. Basically, most C programmers also know Pascal and can program in Pascal because they started taking their first data structures class, probably, or programming class in the university in Pascal. Most people learn Pascal. It's fundamentally clean syntax and great way to do things. It's a great hobbyist language. Whereas C is more of a system programmer's language. If you only program a few hours a week, 3 or 4 hours a week, Pascal is a great language. C is a little difficult.
Borland is now advancing what it considers the next revolution in software design, called object-oriented programming, an environment that features reusable, extendable code. In particular, object-oriented tools stress the underlying architecture of the program's design, using a modular building block approach.
I think maybe one of the first benefits is the fact that object-oriented programming forces careful software architecture. When you're building a piece of software, one of the most difficult things, if you're on your own, is sometimes if you're, kind of a good programmer, is to force yourself to just think about it a lot, architect the house before you start building it. Object-oriented programming, by forcing you to lay out your class hierarchies, etc., forces you to really think things through.
Borland's president sees object-oriented programming as the latest real improvement in software, a step that has been attempted before.
Some people try to make another mutation happen with Lisp languages, with Prolog, etc. But that didn't really work because those languages couldn't do everything the other languages could do very practically, and at the same time build enough new benefits that people would switch to them. Therefore, they became niche tools. I think the present object-oriented programming revolution, to a certain extent, will succeed just as structured programming succeeded, but without having to change those languages by extending them.
George is co-founder and vice president of Digitalk. Next to George, Bruce Newberger with the Whitewater Group. Jan?
Bruce, before we even get started, there's two types of object-oriented programming languages. One is the sort of the pure type, the one that was built from ground up to be object-oriented, such as yours and such as the Smalltalk. The other is the enhanced procedural languages. For your type, which is built from the ground up to be object-oriented, is it easier for a novice who doesn't have the background of procedural languages, or is it still better for a existing programmer?
Well, that all depends on the person's background, but we found that if someone completely jumps feet first into object-oriented programming, it's sink or swim, and most often they swim.
George, let's get started by taking a look at Smalltalk, which is operating here in the Presentation Manager environment, correct?
That's correct.
And tell us about Smalltalk, and then show us how you would use Smalltalk.
Well, Smalltalk, and this is a particular implementation for Presentation Manager, is a pure object-oriented language. It pioneered a lot of the concepts in object-oriented programming, and that's why it's gathered a lot of interest over the years.
In fact, this goes way back, doesn't it?
Oh,
The
yes.
Xerox PARC
Goes
days
back
and
to
so on.
Xerox PARC days and so forth.
All right, show us how you would use Smalltalk 5 here.
Well, in this particular window, it's graphics demonstration windows. We can do various things. We can draw pictures. These particular pictures you're seeing are generated by the underlying Presentation Manager graphics models. This piece of text is generated by the underlying outline font technology inside Presentation Manager. But what we've done here is we've actually surfaced the, this is an object that we can manipulate. In this case, I can drag it around and actually throw it much as a Frisbee. But one of the things that's very interesting about object-oriented environments, in particular in Smalltalk, that I like is the ability to modify things even while things are running. So what I'd like to do is go in and maybe draw something slightly different here.
Okay.
And to do that, what we have to do is locate the piece of code that is doing what we're seeing and then change it. This particular window that I just put up on the screen is a window that allows us to modify code. It lets us see all the source code in the system, and what I'm doing is I'm going to the piece of code that actually drew that. It is called graphics demo, not surprisingly, and the particular piece of code that drew that, not surprisingly, is called Smalltalk.
Right, there it is.
So what we'll do is we'll come down here and change it now. Because I am not necessarily the world's greatest typist, we'll go and pick up a piece of text that I wrote previously and just copy it and put it in the code that we're running.
So you're modifying the program while the program is running.
Right. What I'm doing now is the simple text editing part, which says what you want it to do, and I'm changing it to be something different than what it was. In this case, I changed the text. I'm going to change the size. I'm going to come down here also and change the color. And if I'm as good a typist as I hope to be at times, then it's just a matter of asking the system to compile it. And at this point, it's now into the system. And it's finished with the compilation process now, and it's dynamically bound into the system, so we can now try and run this piece of code. What I'm doing it now is asking to execute it, and at this point it's going out to the outline font and rendering this new string that we put in.
There it is.
And there it is, read as we hoped, slightly smaller, but longer.
And it's another object, you can play
It's
with it
another
just
object.
like
I
the
can
first
pick it
one.
up just like
That's
the first
great.
one, manipulate it and throw it. And for those who were observant, you noticed as I was doing all of that, the first
That's right.
was still bouncing around, which is indicative of Smalltalk's versatility and PM's multitasking capabilities.
Bruce, I want to turn to Actor now and the new version of Actor 2.0 and tell us how that's different from what we've just seen here in terms of an OOP language.
Okay, well, it's very similar to the way we use object-oriented programming. It's the environment that's somewhat different. We run in Microsoft Windows, which can generally run on a smaller machine, and our syntax is a little more traditional, so C and Pascal programmers can find it very readable.
All right, run us through Actor 2.0 here and show us how we would use that.
Okay, sure. This is our new version, and it comes up right in Windows. It is itself a Windows program, and we can see the Actor introduction screen here. Okay, then we can actually go into this workspace and start executing code.
Okay, what are we looking at in this workspace?
Okay, we're looking at some code that creates a new window.
Okay.
This is called an edit window. We press one line. We have one line of code to create it and one line to show it on the screen. And it can be resized and typed into. And you can see that we're about halfway to a word processor here, and this is something that comes predefined in Actor right out of the box. If we shrink the window down a bit, you can see that it even has scrolling. One of the nice diagnostic tools in Actor is what we call the inspector, and we can actually highlight the name of that window object and click on inspect, and that will bring up the inspector, which shows us all of the data that actually makes up that window. For example, its location rectangle on the screen, its caption, and even the text that I just typed into it.
There it is,
So I can learn a lot about the objects in my system at any one time. The next thing I'm going to do is create another type of window called a chart window. And this is a little bit more sophisticated of a program, and it shows business charts on the screen. We can open a file just as we would in any other application. And this is a chart file in particular, and this shows a vertical bar chart. And we can change this to a pie chart, and you can see that it resizes and redraws, and it's quite colorful. And this is a standard type of application you might create in Actor.
Is this one of the predefined libraries?
In fact, this is not. This is one of the sample programs that we distribute to our customers on an as-needed basis. But it's a good sample of what you can do in Actor. What I'm going to do is I'm going to move this off to the side, and I'm going to bring up our browser window, which is similar to the Smalltalk one, and it allows us to look at our code. I'm going to scroll down to the chart classes, and you can see the hierarchical relationship between the charts. Chart is the superclass, and it has 3 descendants of different types of charts.
So those can all inherit the properties of chart.
Exactly.
Yeah.
Now I'm going to highlight the chart class, and we're going to bring up the draw routine. It actually shows us the source code right down here. You can see it's a fairly traditional syntax. What I'm going to do quickly is add in a line of code that just brings up what we call an error box or a dialog box, and it's going to say hello world. And we can do that in about 1 line of code. We click on accept, and that compiles in. And now, as soon as I go back to my chart window and it starts to redraw, I get the hello world dialog box, and I've now actually changed the program.
Right.
So there's a good introduction to the Actor environment, and I'd like to quickly show you a sample program written in Actor. I'll delete that file I just created. And this is a program called Astro. It was developed by physics professors at the University of Maryland, and it's used by courseware in a physics course.
Really a non-programmer doing this.
Exactly. And Windows is known for having a fairly complicated programming environment, and they were able to do this with not that much work. And
That's
as
a
you
little
can see,
astronomy tutorial there.
The scroll bar on the bottom,
Yeah.
what does that do?
that would actually increase the speed, so hold on, and we'll send the
That's
solar
great.
system into,
I'm getting busy.
into a whirl. This also has a help system built in, and people can scroll through it. So this gives you an
That's great.
idea of an actual final program that was developed in Actor.
Bruce, thank you very much. Now, of course, object-oriented programming takes place in other than the PC-compatible Windows and Presentation Manager environments. For the Macintosh, there's Mac App and a new software development system called Prograph. Here's a report.
The Macintosh is a natural for object-oriented programming. Indeed, HyperCard and HyperText are really examples of object-oriented environments. The graphic interface of the Mac often confuses people into thinking that is the object-oriented programming.
There's a tendency sometimes for people to say, well, the Macintosh is an object-oriented computer because it has all these graphic objects lying around on the screen, folders that look like file folders for icons and so forth. And although those could be called objects in one sense, they're not in the strict object-oriented programming sense. They're not, because they don't really have individualistic behavior. They're simply graphic representations that the user can go click on and something happens because the system knows how to do that.
Apple's Mac app is one example of an object-oriented programming language. But the newest object-oriented development system for the Mac is Prograph from TGS Systems.
Apple has been saying very loudly and very clearly to all the developers, you should learn to use object-oriented programming techniques, and specifically their own object-oriented environment, which is called Mac app, or you're going to be unable to program the next generation of Macintosh.
A Prograph program is created by building what looks like a data flow diagram. Prograph features a built-in source code debugger, and a Prograph program can be executed from within the design mode. As an object-oriented language, Prograph features a hierarchy of system classes that correspond to the typical interface elements of Macintosh applications. Working with Prograph requires learning a different style of thinking, but once you get it, you can easily and quickly build a complex application.
Object-oriented programming lets programmers build things far more efficiently. Each application you build in an object-oriented environment, particularly if you don't radically change the type of thing that you're doing, can build significantly on the previous work that you've done, on the previous objects that you've built, on the previous libraries you've created. So each one gets easier in a shorter time frame and more sophisticated.
For the Computer Chronicles, I'm Maria Gabriel.
Group leader for the next project at Frame Technology Corporation. Next to Bill, Sam Drucker, R&D manager for Zortech Incorporated. Jan?
Bill, you're developing products using Objective-C, which is fundamentally an object-oriented extension of an existing language, C. Can you give me background on why you're using an object-oriented language?
Well, the major advantage of object-oriented programs in general is their ability to encapsulate the complexity of a program into objects, such that a programmer can ask an object to perform an action without knowing how that object will implement it.
And Sam, you agree with that?
Yes, absolutely. When you use object-oriented programming, you can use an object interface, thus separating things from parts that they really don't need to know about. For instance, a graphics system classically could be called to an object, and the caller has no idea how such things are implemented.
All right, Sam, you've developed C++, and tell us what that adds to C, and then show us a little bit about what C++ looks like.
Sure. C++ adds to C the ability to define your own data types. For instance, in this program, we've defined a type directory here. And what this has done is abstract the details of how the actual operating system goes out and finds out what files are in your subdirectory into this one object. This object, it looks a lot like C, and as far as C is concerned, it is. Right there, we take the object and we ask it to tell us what the first directory is, or the first file in that directory is, and then we ask it what the next ones are. It's just like C, except we've added this abstraction to pull away from your program exactly what's happening at the operating system level.
All right, Bill, now you're using Objective-C at Frame Technology to do your development work, and tell us how Objective-C works, and give us some examples, if you could, with FrameMaker.
Sure. One of the things that you should know about Objective-C is that, or about Next rather, is that they provided not only Objective-C, but a lot of the other elements that are necessary when one is doing object-oriented programming. Object-level debuggers, also a predefined classes, and something called the application kit, the toolkit, and the music kit, so that we don't have to write those objects ourselves.
What about interface builder?
Yes, that's the last element that they've included, which is a program which allows us to quickly create the interface to FrameMaker. What you see on the screen right now is one of the dialog boxes that comes up in our product. It happens to be license information. Everything in here is an object, including this frame logo over on the right. If I look at Interface Builder, now Interface Builder is displaying this same dialog. Each of these is an object. I can actually click and drag them and design the interface any way that I want. Once I get it correct, I can include this in FrameMaker, and we end up having a completed product. However, what's important to realize is that this is not static. What's being created is actually objects which we can send messages to. That can be shown in this Objective-C program here, which at the top, it is going through various code to find that dialog box, to find the particular frame logo. And the line here I have highlighted is an Objective-C, classic Objective-C statement where there is an object on the left, frame logo, and we're sending the message move to it to tell it move 250 pixels to the right and 0 up and down. The result of that is you can see that the dialog box I have here, the frame logo has moved.
Okay, again, so you can deal with that object, not really have to know what's going on underneath, but just tell it, here's what I want to accomplish.
That's right. It knows how to display itself.
Yeah.
It knows how to move itself.
All right, Sam, what are the consequences here to a developer of having something available like object-oriented programming? How does it make the development of software different?
It makes the development of software different in that your programs are much more compartmentalized. That is, the details that are pertinent to one section of the program never appear in a section of the program that they're not pertinent to. So all my operating system stuff is in one place. All my graphical calls are in another place. So if I have to change part of the program, as you do in any software, part of normal maintenance, it doesn't affect your entire program. It just changes those things that are local to whatever it is that you've affected.
Yeah.
Makes debugging a lot easier, too.
It does.
And in C++, suppose you're a C programmer. I mean, can you work easily in C++? Can you go from one to the other?
Absolutely. C++ is a complete superset of C. As a matter of fact, I can show you how to change a C program into C++.
You pretty much have to be a C programmer to use it?
Yes. C is really the first step into C++.
Okay, describe what you're doing on the screen now, Sam.
If I had a C program called thing.c, then this command would change a C program into a C++ program.
That's it?
That's it.
Okay, it's not too hard to figure that out. How about, Bill, from an end user's point of view? What are the benefits to an end user of having developers have access to object-oriented programming languages?
Well, in the particular case of Objective-C, it has something called dynamic binding. And what this means is, in the case of our FrameMaker product, the product that gets delivered to customers is a combination of the code that we have written and what Next Corporation has built, has delivered. If Next decides at a later date that they want to improve their code, all they need do is to send customers these updated objects, and suddenly FrameMaker benefits from it. Its behavior changes because we're using the objects that Next has shipped to their customers.
And Sam, what's the next step here in making, I mean, object-oriented programming is such a nice move forward to make it easier to manipulate code. What would happen next, do you think?
Well, that's
to
really hard to
borrow a
say.
phrase, if you don't mind using that word.
Well, it's always hard to say what's going to come next in the computer industry. But as far as object-oriented programming is concerned, now that we've got viable tools and system tools, we're going to see a lot more things like the interface builder on the Next. And we're going to see that spread to a lot more platforms for a lot other uses, I think.
Gentlemen, thank you very much. That's our look at object-oriented programming languages. We'll be back in just a minute with this week's computer news.
Has introduced the LaserJet 3. According to HP, this LaserJet printer offers higher print quality, font scaling, and faster graphics, all at $300 less than the LaserJet 2. The LaserJet 3 is compatible with the 2 series and costs under $2,400. Lotus and IBM have jointly announced a new spreadsheet designed to facilitate enterprise spreadsheet computing. This allows users to integrate personal computer and mainframe applications and tap resources such as IBM relational databases. The new spreadsheet is called Lotus 123M and is based on 123 Release 3. 123M will be exclusively marketed and supported by IBM for the System 370. Prices will depend on processor size. The cost of a Macintosh SE and LaserWriter 2 just went down. Apple Computer is cutting prices between 10 and 17% on all Macintosh SE and SE30 computers, as well as the LaserWriter 2 NT and NTX. That means a savings of between $300 and $1,000. IBM has also announced price cuts of 5 to 28% on all its Pro printers. Savings on the 6 Impact printers range from $50 to $170 off. Well, this week, a viewer asks Dr. John about transferring files from his old desktop to a new laptop. Is there an easy way to do it without buying a transfer utility?
Since your desktop is one of the older machines, the chances are the diskettes that it uses will not fit into your laptop. Therefore, the best way to connect them together is using a serial cable like this one. It'll go between your two COM ports. Now, once you've got them connected together, you'll need to use some kind of utility program like LapLink 3 to connect the files from one to the other. Transferring the files using this kind of a utility works really well. If you decide not to use a utility like that, your alternative is to use the DOS copy command. If you do use the DOS copy command, however, be sure that you use the mode command beforehand to match the output of the two ports. Otherwise, you'll get nowhere. For the Computer Chronicles, I'm Dr. John.
Hewlett-Packard is the first to offer a computer built around Intel's 486 chip and ESA technology. The new Vectra 486 series includes 4 models, each with 2 megabytes of RAM. Prices range from $10,000 to $20,000. Well, Steve Jobs has told reporters that a color version of his next computer will be introduced later this year. Jobs is quoted as saying the Color Next was delayed while waiting for development of a 32 bits per pixel version. Jobs also promised that Next machines will support Pixar's RenderMan 3D photorealistic graphics software. Well, this week we take a look at the top-selling software programs for the Mac, according to Mac Connection. Macintosh still leads the list, followed by Adobe Type Manager, Symantec's antivirus application called SAM, Quicken, and Grammatic. Also in the top 10 this week, ThinkC, object-oriented programming, Microsoft Word, Sum2, Symantec's utilities for Mac, After Dark security system, and Type-Align for ATM. 20-some years ago, Timothy Leary encouraged the use of drugs for mind expansion. Now he says computers serve the same purpose. Leary says instead of drugs, today he uses computers to explore and discover his brain. Leary, who currently runs a software business, recently spoke to students at Fresno State University. He recommended they use computers to expand their minds and learn to question authority. That's it for this week's Computer Chronicles. I'm Maria Gabriel.
The Computer Chronicles is made